Welcome to this module. In the last module what we have seen? We have seen the microfluidic chips and its application in drug screening, right, whether it was a case of selecting a particular drug from the set of drugs, or we discussed about a little bit about immunotherapy, where we can design a microfluidic platform that will act as a patient centric platform to help a clinician to select a particular drug for for that particular patient, right. So, it will be like a interface between a patient and a selection of a drug, where the platform itself will help the clinician to determine which drug to use. So, the point here is the use of microfluidic chip. When you are discussing about microfluidic chip, it comes under microfabrication, right, and then whether if you include interdigital electrodes or a micro heater, it becomes a sensor, right. Now, one such sensor that we will be discussing in this module is called VOC sensor. Now, what exactly VOC means? VOC stands for volatile organic compound. Now, what is volatile organic compound? Right? The organic compound that is volatile in nature. For example, acetone, for example, methanol, for example, ethanol, propanol, right. You can also take an example of petrol, diesel, kerosene, right. These are all volatile organic compounds. Now, why to determine or why to fabricate a sensor that can detect volatile organic compound? What is the use of that? So, volatile organic compounds are not only found in chemical laboratories, but they are also available in paints. In the paint that you use at home, there are VOCs. Same thing, our breath that we exhale contains lot of volatile organic compounds, and if that is the statement, then what can be the application? The applications are enormous. How? If the breath contains several volatile organic compounds along with carbon dioxide, humidity, and if a person is suffering from a particular disease, then will the volatile organic compounds in the breath changes? So, how it can be used? The research says that for a person suffering from ketosis, is a diabetes, all right, will exhale a higher concentration of acetone compared to other volatile organic compounds. Same way, a person suffering from lung cancer will exhale a higher concentration of nitrogen oxide compared to other volatile organic compounds. That means, if we can understand the breath signature, we can identify whether a person is suffering from a particular disease or not. So, I give an example, right. I give an example of what? I give an example of a person suffering from ketosis. I give an example of a person suffering from tuberculosis, lung cancer. Now, there is another example of tuberculosis. Okay, I have not given you example till now of tuberculosis, but that can be another application of the volatile organic compound sensing devices. In case of tuberculosis as well, there are certain sets of VOCs that are in higher concentration compared to the other VOCs that are found in the breath. Thus, if you can develop a system that can understand or study the breath signature, then it will be a non-invasive way of determining a disease. So, what I mean by invasive? Invasive is when you cut the body and you place something within the body. For example, there is a knee replacement, right. Then you have to cut the body, cut the part of that particular the organ, right, and you have to place a new organ, right, or a place of fixture to help that organ to work properly, right. Invasive, you are going inside the body, invasive. Minimally invasive is like a glucometer, you prick the finger, minimally invasive. Or catheter ablation, minimally invasive. Open heart surgery, invasive. What about non-invasive? Non-invasive is where you are not using any device within the body. You are not using invasive method, you are not using minimally invasive method. So, understanding the breath signature will be a non-invasive way of understanding the disease or determining the disease. So, how can we design such sensors, and whether designing such sensors will be sufficient for us, or we need to integrate some other modalities to come up with a solution. So, what do I mean by that? You see, when I have array of sensors, right, then the array of sensors becomes like our nose. If you talk about nose, it has lot of sensors, correct, and those sensors through the olfactory lobe are connected to your brain, that is your neural system, right, or neural network. So, then the nose is just a sensory organ, like it can smell, but how we feel, like how we know that the smell of an orange is different compared to smell of a mango, right, you can easily delineate, right. How? Because based on the outputs of the sensor, the brain has been trained that certain number of VOCs present in a particular pattern will be of orange, whilst the way that mango will smell would be different because of the presence of different kind of smells. So, you have to train your brain, you have to train the neural network. The neural network is connected with your nose, which are array of sensors, and that is why you are able to distinguish between two different fruits, or in fact many fruits. Not only that, we are blessed to have lot of sensors, we can see the fruit, right, vision, somebody telling us ear, audio, we can taste and we can delineate whether it is orange or mango, right. So, we have several sensory organs, we can even feel it. If you hold a mango and if you hold an orange, you will understand the difference, right, touch. So many sensors are already within us. What we want to understand is, can we replicate the nose with the neural network, and that can be done when you fabricate sensors which are meant to detect VOCs, but single sensor cannot be sensitive and selective, and that is why we want to have group of sensors, and this group of sensors we need to the output data needs to be fed to a neural network, where then a neural network can be trained, and thus we can make an electronic nose, which is an artificial nose, right. So, we will be learning as a part of this course how to design electronic nose, and in detail how to design a sensors that can be fabricated, that can be integrated to the entire system. All right. So, If you see the slide, we will be discussing on novel techniques for MEMS based VOC sensors using nanostructure metal oxides. Now, I will when I will explain you the fabrication, I will tell you the importance of nanostructure, right, why we have to go for nano, all right, and the idea is to develop a non invasive technique for detecting diabetes. Like I said, the VOCs are found in individual breath in hundreds of parts per million range, and only a small number of VOCs are common to everyone. The concentration of VOCs exhaled by patient for different disease is different than in the healthy patient or in a healthy person. VOC sensing is important in environmental monitoring as well as medical diagnosis. So, if you see what are the health effects of pollution, right. First is if there is an air pollution, right, the quality of air is not good, then what kind of effects can be there? It can be the nerve damage, it can be because of this cancer is there, nausea is there, skin irritation is there. So, if you are talking about the VOCs exceeding the certain limit causes us cancer, causes nausea, causes skin irritation. If there is a particulate matter and ozone, it causes respiratory illness. If there is a lead in the in the air, then we have a nerve damage. So, the health effects of pollutions are enormous. The second one is water pollution. What if the water is polluted? If the water is polluted, then there are bacteria, parasites, chemicals, and that can have the fatigue, that can have headache, right. Same thing, if there is a pesticides in the soil is contaminated, then there can be nausea, there can be cardiovascular diseases, there can be fatigue, and there can be gastroenteritis. So, the point is that the VOCs from the pollution that we are talking about, and from air, water and soil pollution we are talking about, we are focusing on air pollution, and from air pollution we are focusing on volatile organic compounds. So, you can see that volatile organic compounds in particular are responsible for causing skin irritation, are responsible for causing nausea, and are responsible for causing cancer risks. So, we are interested in developing sensors for VOC, all right. So, how to fabricate the sensor, all right. So, we will be looking at fabrication of sensor. I will teach you in detail, but how the sensor would look like. A sensor, if I draw a cross section, then and if I am using a metal oxide semiconductor, metal oxide semiconductor material, a metal oxide semiconductor material is sensing layer, right. How my VOC sensor, volatile organic compound sensor, should look like, all right. That is what I am drawing in the schematic. If I have a fabricated a sensor using metal oxide semiconductor material, how the sensor should look like. So, we will use an oxidized silicon substrate. Just ignore my drawing skills. So, this will be my silicon dioxide, this would be silicon, and again this one would be silicon dioxide. Now, if I am using metal oxide semiconductor as gas sensor, I need to heat it up. So, I will have a heater, on heater I will have an insulating material, on insulating material I will have an interdigitated electrodes, and on interdigital electrodes I will have a sensing layer. You got it? This is my nichrome heater. This is metal oxide semiconductor sensing layer. This will be my interdigitated electrodes. It can be chrome gold. This is how my sensor should look like. Alright. Now, if you know, if I take a silicon wafer, right, and I draw cross section of silicon wafer, which will be like this, correct. Now, how I have etched this silicon dioxide, sorry, I etched the silicon wafer, this is silicon, but if you see this particular sensor, then here we have a substrate which is like this, is not it. How to etch silicon or bulk of silicon? For that we have a technique called bulk micromachining. Bulk micromachining. Alright. So, we will discuss this thing, and then how to grow oxide layer, how to grow how to deposit heating material, how to pattern heater, on that how to have another oxide layer, right, because you see this one is another oxide layer, this one is another oxide layer, because you cannot have two metals one over each other, because it will get shorted. You got it. So, this is one way of creating a sensor. There is another way of creating a sensor will be bulk plus surface micromachining. Surface micromachining. Alright. We will see what is bulk micromachining, what is surface micromachining when we understand what are MEMS. MEMS stands for micro electromechanical systems. Alright. So, this is example of such a sensor. We will discuss how to fabricate this in some other module. Right now, you see that this sensor number 1 and sensor number 2. Sensor number 1 is fabricated. First is a heater. You can see this is an heater, right. Then on the back side there is a pit that is created by etching the silicon wafer using bulk micromachining. Then we have we just want to know what is the maximum temperature the heater can achieve before it starts breaking. On that heater there are interdigital electrodes, which you can see made up of aluminum electrodes. On this interdigital electrodes we have indium tin oxide based thin film. ITO stands for indium tin oxide, based thin film. We will discuss how to deposit this thin film. Now, why if there is a sensing film or if there is a thin film, how can we see the interdigital electrodes as well as the heater? How we are able to see? How we are able to see the interdigitated electrodes and how we are able to see the heater, right. The reason that we are able to see even though there is a presence of indium tin oxide is indium tin oxide, zinc oxide, tin oxide, indium oxide, these are all transparent conducting oxides, transparent conducting oxides or TCOs. transparent conducting oxides or TCOs. Thus, in the fabrication of solar cell, people have started using ITO for contact, ITO for contact. Now, there is another way of fabricating a sensor, that is sensor number 2, which is bulk plus surface micromachining based sensor. Alright. And here what you can see, there is a creation of a pit. I'll tell you how to create it, do not worry about it. Just understand that from the silicon wafer that we have created a pit like this. Alright. And then we have used a surface micromachining to bulk micromachining to create a pit. On that pit we have filled the material with zinc oxide, then we have planarized the material, alright. On that we have a micro heater, on micro heater there is an insulator, after which we open the contact of the heater, then we have interdigital electrodes, then we have a sensing layer. Now, this is a nanostructure of zinc oxide, that is why you cannot see the interdigital electrodes below it. And then we open the windows on 4 sides and etch the zinc oxide that we have deposited initially. This zinc oxide will act as an sacrificial layer, do not worry about it, we will discuss this thing in the class where I will be showing how to fabricate this particular sensor. The point is, whether the advantage of this particular technique is that now you can see that the heater requires less amount of power compared to this, because it has to heat only a few microns of layer, where in this case it has to heat about 100 microns of the diaphragm. So, the power consumption in sensor number 2 is less compared to power consumption in sensor number 1. However, the mechanical stability of sensor 2 is poor compared to mechanical stability of sensor 1. Alright, so this is the end of this particular module. Let us see in the next module how can we fabricate a flexible sensor and how can we fabricate a strain gauge followed by the actuators. Till then, if you have any question, please free to ask me, ask through the forum, and I will see you in the next class.